Hello dear students. Last time we have discussed that first year topic, that is thermal properties of matter. Now let us discuss the second year first topic, that is the electric charges and fields. Here the first, let's go for electric charge. This is a property acquired by a material due to loss of electrons by it or gains of electron. So the charge is always associated with the body when that body should lose or gains the electron. So now there are two main properties of elementary particles. One property is the electric charge, and the other property is the mass. Here many number of fundamental particles or elementary particles are there. Among them the most important are those are electron, proton and neutron. And about any other fundamental particles like bosons, mesons, hadrons, let us discuss in the fundamental particles in the nuclear lesson. Now let's go first of all the property, that is electric charge. The least available charge in this universe is 1.6 into 10 power minus 19 coulomb. This least possible charge in this universe is called as the fundamental or elementary charge. And here if you take any object or any material, that material having no charge smaller than this value, therefore this is the smallest possible value of charge in this universe, and this charge is called as the elementary or fundamental charge. And this charge is associated with the two particles. Those two particles are one is electron and other one is the proton. Here the electron charge Q is equal to minus E. Minus means what? Minus 1.6 into 10 power minus 19 coulomb. Whereas for the proton the charge Q is equal to plus E. Here that is equal to plus 1.6 into 10 power minus 19 coulomb. Here all of you should keep in mind that these two charges are equal in magnitude but opposite in sign. But it does not mean that the negativity of electron does not mean that it has a smaller charge than the proton. Therefore now both are having the equal and opposite charges. There is no meaning of smaller, there is no meaning of larger value of any charge. If you come to the particle, that is the neutron, for the neutron the charge is equal to 0. Neutron does not having any charge for that. The masses of the three particles are, for the electron the mass is 9.1 into 10 power minus 31 kg, and for the proton the mass is 1.6725 into 10 power minus 27 kg, and for the neutron the mass is 1.6750 into 10 power minus 27 kg. And here one point you should keep in mind, that among all these three particles the electron is the smaller, very smaller particle compared with the proton and neutron. Why? Because the mass of the electron is very smaller than the mass of the proton and the mass of the neutron. Therefore the mass of the proton or neutron is almost all 10 power 4 times. Means what? 10,000 times the proton and neutron both are bigger than the this electron. Therefore now electron mass is the smallest, and next the proton, and the highest particle which has a mass is, that is the neutron. But here one more observation point, that the difference between the proton mass and neutron mass is very small. Therefore almost all both are equal, but a very little amount the neutron having the more mass for this. And under steady state condition, means what? For every atom under stable condition the number of electrons are equal to number of protons. Means what? How much negative charge is there produced by the electron, that much of the positive charge is there produced by the proton. Therefore under stable condition the total charge of the body is 0. When the total charge of the body is 0, that body is called as the uncharged conductor or uncharged material, or we can call as the neutral conductor or neutral material. But when a body is disturbed, it is a stable state. What is the meaning of disturbance of the stable state? Means what? If the body, by doing any process, if the body loses the electron or gains the electron, then the body becomes the charged body. Therefore to get the charge on a body, the body either should lose of its electron or it should gain the electron from any other object. Therefore when a body loses electrons, it becomes a positively charged body. Why? Because when a body loses the electron, the number of protons more than the number of electrons. Therefore the positive charge produced by the protons is more than the negative charge produced by the electron. That's why more positive charge is there. That's why when a body loses electron, it becomes a positively charged body. Similarly, when a body gains electron, it becomes a negatively charged body. Why? Because when a body gains electrons, so the number of electrons in the body is more than the number of protons. Therefore, the negative charge is more than the positive charge. Therefore, now the charge on the body which gains the electron is a negatively charged body. So, if n is the number of electrons gains or lost, therefore the charge on the body is Q is equal to plus or minus Ne. Here Q is equal to plus Ne we have to consider when the body loses the electron, and Q is equal to minus Ne we have to consider when the body gains the electron, where n is the number of electrons lost or gains, and E is the elementary charge. That charge is 1.6 into 10 power minus 19 coulomb, as we told already. Now, generally mass of the electron is very small, we know that, but mass of the electron is one finite value, that is 9.1 into 10 power minus 31 kg. Therefore, when a body loses its electrons, it also loses its mass because of finite amount of the mass of the electron. Similarly, and vice versa, when a body gains the electron, it also gains the amount of the mass also. Therefore, when a body loses the electron, its mass decreases, and when a body gains the electron, its mass increases. Therefore, now, for example, if n is the number of electrons lost or gained by the body, therefore the loss or gain of the mass by the body is given by, that is m is equal to n into me. Here, where n is the number of electrons lost or gain, or me is the mass of the electron, that is 9.1 into 10 power minus 31 kg. Now, one more very important point for the problem solving, which is also useful in the Coulombs law of electric force concept also. For example, when two spheres of initial charge Q1 and Q2, let us consider two spheres. The first sphere charge is Q1, second sphere charge is Q2, and those radius R1 and R2, and these two radius are both are in physical contact. When both are kept in physical contact, therefore charge will be transferred from one body to other body, and after sharing the charges, the new charge on the first sphere, let us suppose that is a capital Q1, and a new charge on the second sphere, that is suppose that is a Q2. Now, what are we know that the initial charge Q1 and initial charge Q2 on second sphere, and the radius of the each sphere also we know. And when both are in physical contact, either by direct physical contact or by connecting by conducting one conducting wire, therefore now by conducting wire, now the new charges on the spheres are Q1 and Q2. The formula for this are, the new charge on the first sphere Q1 is equal to R1 by R1 plus R2 into Q1 plus Q2. Here Q1 plus Q2 is the total charge of the system, and the new charge on the second sphere Q2 is equal to R2 by R1 plus R2 into Q1 plus Q2, and these are the new charges on the two spheres. Now, if the two are identical spheres, means what? If both are identical spheres, means what? The radius of the each sphere must and should be equal. Therefore, R1 is equal to R2, that is for example R. If you substitute here, you can get that the charge on the first sphere becomes Q1 is equal to Q1 plus Q2 by 2, and the charge on the second sphere, that is equal to Q2 is equal to Q1 plus Q2 by 2. Here we can understand from these two values that both are sharing the charge equally after connecting through a conducting wire, or after connecting them through a physical contact. This electric charge causes the electric force of attraction or repulsion between any two charges. This force is given by the Coulombs law, and this Coulombs law let us discuss now. And before starting the Coulombs law, just you keep in mind, we know that the SI unit of the charge is the coulomb, but here sometimes they will give that some practical units also. Here 1 millicoulomb is equal to 10 power minus 3 coulomb, 1 microcoulomb is equal to 10 power minus 6 coulomb, 1 nanocoulomb is equal to 10 power minus 9 coulomb, 1 picocoulomb is equal to 10 power minus 12 coulomb. And this these are the practical units for the charge which are helpful for solving the problem. Now let us discuss the most important task of this lesson, is that is a Coulombs law. Generally, in the first year in the gravitation lesson, we have seen that the universal law of gravitation, which is given by the Newton, and in that we have discussed that the gravitation force between any two masses can be calculated by using that law. Here, similar way, Coulombs law is used to find out the magnitude of electric force between any 2 point and stationary charges. Let us consider if Q1 and Q2 are any two charges with a separation r between them, then if they are in. Now here let us consider this is a Q1 and Q2 are the two charges, and this r is the distance between them. The electric force of attraction between these two charges or repulsion between these two charges depends on very two important properties. One is the units we have used, means what, whether you are using SI units or CGS units, and also depends on the medium between the two charges, means what, where these two charges are present, either in vacuum or in any other media. For example, if these two charges are present in any free space or vacuum or air, here sometimes they will give that free space or vacuum or air, all are considered are the same. Therefore the force of attraction, force of repulsion can be given by F naught is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Here 1 by 4 pi epsilon naught is a constant. That constant value is 9 into 10 power 9 Newton meter square per Coulomb square. Here this property epsilon naught is called as the permittivity of free space. That's value also given 8.85 into 10 power minus 12 Coulomb square per Newton meter square. If these two charges are present in any other medium other than free space, then the force, here you see the force in free space is F naught. Here the force in medium I am indicating with F. Therefore F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Here one more difference is that here we have used epsilon naught, which is the permittivity of the free space, and here epsilon is the permittivity of the medium. And here 1 by 4 pi epsilon naught has not a fixed value, and it has different values for the different media. And in terms of the permittivity of free space, the permittivity of the medium also can be expressed as that epsilon is equal to epsilon naught into K. Here one more constant K is called as a dielectric constant. That dielectric constant is also called as a relative permittivity, and here K is equal to infinity for metals, and K is equal to 1 for vacuum, and K is equal to 80 for water, and K value is always greater than 1, it never be lesser than 1, and K is never be equal to 0. Now generally these formulas, F is equal to 1 by 4 pi epsilon naught and F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, and these two formulas are valid when the unit used is the SI system. Means what, charges, distance and force, we have to express them only in SI unit, then only these formulas are valid. But whenever the distances and charges are expressed in CGS unit, just you substitute that 1 by 4 pi epsilon naught is equal to 1. This is the value of 1 by 4 pi epsilon in CGS unit. Therefore automatically the part becomes force in free space F naught is equal to Q1 Q2 by R square in free space, and F is equal to 1 by K Q1 Q2 by R square in any medium. And one more important point is that the force of attraction repulsion between any two charges in medium and in free space is given by our relation F is equal to F naught by K. Here K is greater than 1, we know very well. Therefore now F less than F naught. Therefore the force is always maximum and when the two charges are in any in free space only. Therefore now when the two charges are taken into medium, therefore the force is going to be decreased as due to one property. That property is nothing but the permittivity of the medium. Therefore now here permittivity of the medium can be defined as a property of a medium. It is not property of charge, it is a property of medium which causes the change of electric force between any two charges. And here one more important point for the problem solving. For example, these two charges are separated by a distance r. In between them, let us put one dielectric material of dielectric constant K, and T is the thickness of the material. Therefore when you keep one dielectric material in these two charges, the effective distance becomes capital R is equal to R minus T plus T root K. Here K is dielectric constant, T is the thickness, and R is the initial distance between them. Capital R is the effective distance. And if this material is fully placed with, now this is a partially placed and this is a fully placed. When it is fully placed, therefore now we know that R is equal to T. When R is equal to T, the effective is here, just you substitute here, you can get this part is equal to 0. The remaining is R is equal to small r into root K. And for any conductor, and we know that our metal or conductor, the dielectric constant value already we have seen that the dielectric constant value for the metal, that is equal to K is equal to infinity. Therefore now for any dielectric material, if you substitute here, you can get a K is equal to infinity into anything is equal to infinity. Therefore R is equal to also infinity. And the electric force between them is given by F naught is equal to 1 by 4 pi epsilon naught Q1 Q2 by capital R square. Here don't substitute the small r value. Why? Because here this two charges now separated by a material, and that material, that effective distance is capital R. That's why to find out the force compulsory, you have to find out the effective distance between them. After calculating the effective distance, you have to substitute in this formula, then you can get the electric force existed between them. And if this dielectric material is replaced by any metal or conductor, we know that the K value becomes infinity. When the K value becomes infinity, the electric force of attraction or repulsion between them becomes that is equal to 0. Therefore now when two charges are separated by any metallic conductor, means what? Copper, zinc, aluminium, bronze, etc. Therefore the electric force of attraction repulsion between them is equal to 0. Now let us discuss some problems on this concept, dear students. And first problem is, if your body loses 10 power 18 electrons for every 1 second, what is the time taken by the body to get a charge of 1 coulomb? They are asking. In 1 second of the time, 10 power 18 electrons are coming out from the body. Then they are asking that what is the time taken by the body to get a charge of 1 coulomb? They are asking. Here this 1 second they have given in terms of the number of electron, and here the time also should be taken in terms of the number of electron, but they have not given the number of electrons contained in 1 coulomb. Our duty is to find out the number of electrons present in 1 coulomb of the charge. So now from the formula, Q is equal to NE, the number of electrons in 1 coulomb of the charge, N is equal to Q by E, Q is equal to 1, and here E is equal to 1.6 into 10 power minus 19. And here therefore that is equal to 10 power 19, 10 power minus 19 goes upside 10 power 19 by 1.6. Therefore after solving you will get that in 1 coulomb of the charge, N is equal to 6.25 into 10 power 18 electrons are present. Therefore according to the question, for every 1 second 10 power 18 electrons are coming out. Therefore in what time this 6.25 18 electron or indirectly 1 coulomb of the charge is coming out from the body. Therefore now just you divide them, you can get that T by 1 second is equal to this number of electrons by this one. Therefore here 10 power 18 is cancelled. Therefore now that is equal to 6.25 second. Therefore now in 1 second if 10 power 18 electrons are coming out, therefore in a time of 6.25 seconds, therefore 6.25 into 10 power 18 electrons are coming out. Now let us discuss one more problem. A body gains a charge of 3.2 into 10 power minus 18 coulomb. What is the mass gained by the body? Already we have discussed that when a body gains a charge or gains the electron, it also gains the mass. Of course it is very small, it can be neglected, but as electron has a finite mass, there is a small increase in the mass of the body also. We know that the mass formula M is equal to N into Me, where N is the number of electrons lost or gained, Me is the mass of the electron, that is 9.1 into 10 power minus 31 kg. Here first of all Me, that is we know, and N we don't know. First of all we have to find out in the given charge 3.2 into 10 power minus 18 coulomb, how many number of electrons are present. Therefore now here from the formula Q is equal to Ne, N is equal to Q by E. Here substitute the given values. Q is equal to 3.2 into 10 power minus 18 and 1.6 into 10 power minus 19. That is becomes 2 into 10 power minus 18, and take this 10 power minus 19 upside, it becomes 10 power 19. Therefore now the answer becomes, that is the N is equal to 20. Therefore in the given charge of 3.2 into 10 power minus 18 electron 3.2 into 10 power minus 18 coulomb of the charge, 20 electrons are present. Now in the formula you substitute the given values. Mass gained m is equal to n into me. Therefore now m is equal to 20 into 9.1. You will get the answer. The mass gained by the body is 18.2 into 10 power minus 13 kg. Of course here due to this minus 30 kg it is very small, and of course we can neglect this value also. And one more problem, last problem of the topic, that is the two spheres of radii 2 centimeter and 3 centimeter with initial charges 5 microcoulomb and 10 microcoulomb are connected by a metallic wire. What is the charge transferred between the two spheres, they are asking. Now here first sphere radius they have given, that is 2 centimeter, and second sphere the radius they have given 3 centimeter, and first sphere initial charge 5 microcoulomb and second charge is 10 microcoulomb. And we know that the charge formulas, the new charge formulas, that is new charge on the first sphere, q1 is equal to r1 by r1 plus r2 into q1 plus q2. Just you substitute the given values in this formula, you will get that r1 is equal to 2 by 2 plus 3 into 5 plus 10. Therefore here 2 by 5 into 15, therefore 5 ones and 5 threes, therefore 3 twos, therefore q1 is equal to 6 microcoulomb. Here you observe the initial charge on the first sphere is 5 microcoulomb and the final charge on the first sphere, that is 6 microcoulomb. Therefore they are asking how much of the charge is transferred. They are not asking what is the new charge on the first sphere, they are asking how much of the charge is transferred. Therefore the charge transferred is the final charge minus initial charge. Therefore now the charge transfer is given by delta q is equal to q1 minus q1, that is 6 microcoulomb minus 5 microcoulomb, that is 1 microcoulomb you will get. Therefore now here not only from the first body charge distribution you can find out the same answer from the second charge also, but here first charge gains the 1 coulomb of charge and second sphere losses the 1 coulomb of the charge. And the remaining problems on the Coulombs law let us discuss in the next videos.